This is not just like some like made up, like let's make, you know, coordinate points more difficult. Like it actually is, it's probably a little more useful in that we know exactly how far we're going. So what I thought we could do here is I did like a little version and then there's like a bigger version on the back. So you're trying to navigate a minefield. So,
we're gonna die.
That's super die.
Well, we're gonna crash.
Super positive here. But the so yes, you can draw a line through there. It's, yeah, the maze is really hard. Like you're like, oh my gosh, I'm never gonna solve this maze. You know where you're going, but you're trying to explain how to get there using polar coordinates. So I'd like to give you guys a little bit of time to get started on it, but I might get you guys started on just the first one so you guys can see. But now one of the things that you realize is once you get to the next point, you start your polar coordinate over again. So that's like your new 0. So if you say you're going 12 as your R, then when you get to your new point, if you go 5, that's a new 5. So like that's kind of why polar coordinates are kind of maybe more helpful in this case, because once you get to the new spot, now we're looking at that's our new like 0, 0. So hopefully this will make a little bit of sense if we do a little bit of an example together. I think the one on the front is probably a little bit more difficult than the one on the back. The one on the back is longer.
Sounds pretty cool.
I'll tell you guys, I forgot to do that when I was in high school because I was the first one in my family to go to college, and I didn't realize that was important. And I would just read everything, and I ended up in like a study lounge, like I didn't have like a place.
I did it like 30
I heard it put your desk tables. What? Yeah, they gave us the study lounge as a room, and so like they had to put like extra drinks on it, but we were kind of living in a room that wasn't like a real. It was big.
Oh, so I feel okay.
Yeah.
We didn't have it, what you guys all had. Yeah. Times were different back in my day. You just had to or you could take your roommates, like a real, like someone like you know, like your friend.
Don't talk to me.
I did it.
Right.
It's like her
All right. So, yeah. So like hardest maze you've ever seen here. So I drew the line going through this. This is like the safe path that we want to travel. So we need to draw or like write our polar coordinates to go from here to there. And you can kind of use like I don't know if you want to pick like an actual like a coordinate point to start at and end at, so it's just a little more exact here. It might be easier to stick with. So I'm kind of going down this straightaway here, and I need to figure out what my polar coordinate is for that. So again, what we do is we basically picture this as like our 0. So what we're going to do from here, and this is not something that, I mean, this is kind of just trying to get you guys to think about how this is used, like, and how we can explain ourselves other than just doing, you know, translating back and forth. So I think the easiest thing to do here is kind of think about this as our triangle. So what does our triangle look like? So if this was my, well, I said black. So thinking of this back as our triangle there. So we're trying to figure out this angle here. And then x and y we should be able to figure out, right? And that would allow us to figure out our r. So we're going to be able to figure out our first polar coordinate because we have this perspective as our triangle here. So I went 7 across. Now it just depends where exactly you ended up. 7 down. Now I didn't mean for this to work out so nicely, but it did. But so 7 and 7 tells me already what that angle is going to be. Yeah, it's going to be a 45-degree angle. So I already know the angle. But now, careful, it's 45 degrees, but what do we actually call it? Not just regular 45. No, like if we're talking about this angle theta, here's our 0 line. Rather than just calling it 45, yeah. It's technically negative 45, because straight 0 would be straight out, so we're going like down, so we're going, clockwise. So, and down here it asks for your first movement. So our first movement would be a negative 45 down. But we need to figure out how far we need to go so that we're still in that safe area. So we have to figure out this distance. Now, if you're comfortable with your 45, 45, 90 triangles, you can just call that 7 square roots of 2. Or you can do Pythagorean theorem. 9.9. And now we're at a new 0. Now these last two are kind of nice. Hopefully they're a little bit easier to kind of figure out. I'm going across here. What's my angle going to be there? It's just going to be 0. I'm just going straight across. And then how far I'm going. 7 across as well, is that right? And that's positive 7, right? Yeah. So again, we're not going back to like the origin. You have your new 0 at each of these spots. So that'd be our next movement. I would tell someone to move there. And then to get to our home base or our safe base here, we're just going straight down. And we're going down 3 here. I wouldn't call it a negative 3 though, because it's just technically 3 in that direction. Otherwise, you'd be sending someone out of like the safe zone if you told them, negative 3. But what's the angle there? If you want to use 270
Or negative 90.
Negative 90, either one. So negative 90 or 270.
Wait, why though?
Because they're the same. So like if we're thinking about this spot here, this is negative 90 or it's positive 270, right? Going back.
Why is there an angle for the straight line?
Because it's this new polar coordinates that.
Because we're using
So
circles
7
still.
would be 360.
What's that?
7, like the 7.
You could have said 360, but picture someone like, again, we're a tank, and you're telling the tank to spin all the way around.
I mean,
So if now the tank is now like, oh, I need to turn 90, negative 90, that means I'm turning this way.
and where do you get like, we don't just put negative 3, not going down
Because that's the direction we're headed. Negative 3 would actually be back up this way.
So
So
Okay, I gotta pretend I'm gonna take this other
negative 390.
Yeah.
Yeah. So again, you're making your tank spin around though, out in the middle of, yeah. All right, so try flipping it over and see if you guys can do this one with, I think it has 5
Do you
movements.
just randomly take what's in the theta?
What?
Do you choose any angle?
Oh, so guys, yeah, maybe the backside we should probably talk about because I didn't mean for that first one to be quite that easy, and it was. How do we figure out the theta if it's not just 45 degrees?
Or I was just asking if any angle could be theta.
Well, so we're like measuring this one here, or like we're trying to figure that one out, right? So that's the way we want to move first, is we want to move diagonally up. And so this is going to be where my theta is. So again, picture yourself standing at 0, 0. You should be able to figure out x and y. What? Yeah, so you're going to use your tangent. And remember guys, we talked about tangent yesterday. We talked about the inverse tangent telling us that angle.